Okay, now we look into an example on problem solving for a flow system with expansion factor. This is part 4 of the lecture. So by end of this lecture, you should be able to apply the concept of stoichiometric reaction order and rate law to solve reaction engineering related problem. Okay, so just to recap on your memory from the previous lecture, so this is the stoichiometric table for a flow system. You have in all the reactant, all the species, reactant and product, and also don't forget to include the inert. And this is the parameters that you use in the table, the definition for each one. Okay, so the last one is the equation for you to include the expansion factor into the calculation for both batch and also for the flow reactor. Okay, so let's look at this example 3.5, determining the concentration of species involved in a gas phase reaction. Okay, so you were given the reaction of 2 SO2 plus oxygen to produce 2 SO3. So a mixture contain of 28% of SO2 and air. So you have 2A plus B producing 2C. Okay, right into the stoichiometric base, taking A as the basis, you divide the stoichiometric, you have A plus 1 over 2B producing C. Okay, so given to you a mixture of 28% SO2. So your YA0 is equals to 0.28. And the oxygen, it says that 70% of air is charged. Okay, so 70% is the air. So air contains 21% oxygen and 79% nitrogen. So your YB0 is equals to 0.21% of oxygen times the percentage of air into the system, 0.72. That will be your YB0. Okay, so the first thing that you need to do is make a stoichiometric table. So you fill up all the species. So you have SO2, oxygen, SO3, and the inert. So in this question, what is the inert? Any idea what is the inert? Remember, we have in air oxygen and nitrogen. So oxygen involved in the reaction. So the inert is the nitrogen. Okay, remember the expression that you learned before this? The expression for volume change for a flow reactor given by this. And also you have CA equals to FA divided by V, which is equals to FA is FA0 times 1 minus X. And you have V equals to V0 plus times 1 plus epsilon X. Okay, then do you remember that FA naught equals to CA naught V naught, and you have FA naught divided by V naught is actually the CA naught. So you replace the CA naught into this part. So you have CA equals to CA naught times 1 minus X divided by 1 plus epsilon x. Okay, now write down the concentration equation for the species B. So you have CB equals to FB divided by V, which is equals to FA naught, recall back from the stoichiometric table, times the theta B minus 1 over 2x divided by V naught 1 plus epsilon x. So which is equals to CA naught times the theta B minus 1 over 2x divided by 1 plus epsilon x. So you do this also for species C and for species C as well. So this is the expression for CB. This is the expression for CA. So for CC will be CC will be equals to CA naught x divided by 1 plus epsilon x. Okay, now we need to find what is the value for each term so that you can write the equation of concentration in terms of the function of x only. Okay, so you have FA naught equals to YA naught times FT naught, which is equals to YA naught is 0.28 FT naught, and your FB naught equals to YB naught times the FT naught, which is equals to 0.72 times the 0.21 FT naught. So your theta B will be equals to FB naught divided by FA naught, which is equals to 0.72 times 0.21 FT naught divided by 0.28 FT naught. So this is, you can cancel, your theta B will be equals to 0.54. Okay, you use the same calculation for theta I, you will get theta I equals to 2.03. And then your epsilon will be equals to YA naught delta I, YA naught delta, which is equals to YA naught is 0.28. The volume, the number of mole change in the reaction is minus 1.5, negative 1.5. So you will get the epsilon equals to negative 0.14. So once you get all the value for the expression for the parameters, what you need to do is now is replace the value into the equation. So you will have CA equals to CA naught 1 minus x divided by 1 minus 0.14x. Your CB will be equals to CA naught 0.54 minus x divided by 1 minus 0.14x, CC equals to CA naught x divided by 1 minus 0.14x, and your CI will be equals to CA naught times 2.03 divided by 1 minus 0.14x. Okay, now you can calculate what is the value of CA naught. Okay, using the ideal gas law, CA naught equals to YA naught P over RT. So for the question, using the data given in the question, you will get 0.1 mole per dm cube. Okay, so now you need to develop a concentration table, concentration conversion versus the concentration table. So you draw a table where you have the conversion 0. You can choose any value between 0 to 1. 0.25, 0.5, 0.75, and 1. So you have the concentration of species A, concentration of species B, concentration of species C, and the concentration of inert. So you replace the value of x into each equation and you will get the concentration at the particular conversion. When you fill up all the table, you use the data to plot a graph. So you will have the concentration versus the conversion of all species. So you have the reactant, both reactant SO2 and oxygen will decrease by the conversion, and the product SO3 will increase as it converted into the maximum conversion. And you will also have inert. So this will be your inert N2. Okay, so please refer to the textbook Fogler, page 115 to 118 for more understanding on this example. Okay, now we have complete chapter 3. So by now you should be able to write the Red law in terms of concentration and the Arrhenius law, and also you should be able to write the stoichiometric table in terms of the conversion and to relate reaction rate and also the concentration. And now we have completed the first 3 basic building blocks to study isothermal chemical reaction and reactors.